Okay, good evening and welcome to all in lecture 3 of live lecture series of subject signal system KEC 403. The topic of this particular lecture is jet transform and its inverse. So in this particular video lecture we will discuss about the jet transform and its inverse, and I am Dr. Amit Garg, Associate Professor in Department of EC, Akgec Garg Engineering College. So let us start with the jet transform. Jet transform is basically the discrete time counterpart of the Laplace transform. Means the things that we have done in case of Laplace transform for continuous time signals, we will do the same things for discrete time signals for jet transform basically. So jet transform is introduced to represent discrete time signals in the jet domain. Means if we'll take the jet transform of the signal, then we will get the representation in jet domain. So jet domain is basically a complex domain where you can say jet is represented by r e to the power j omega, where r is basically the radius of the circle and e to the power j omega is the exponential function, where omega is the frequency. And jet transform is the extension of discrete time Fourier transform, which enables us to analyze certain discrete time signals that do not have a DTFT. So you can say it is basically the extension of discrete time Fourier transform. In case of discrete time Fourier transform, we have seen that for several signals we will not be able to take the discrete time Fourier transform because the discrete time Fourier transform does not exist. So the solution is that for those type of signals is the jet transform, where rather than doing the analysis in the frequency domain, we are doing the analysis in basically in the jet domain, which is the complex domain. In case of DTFT, if we have seen that we are basically analyzing the signal over the unit circle. So you can say in that case z will be equal to e to the power j omega, or you are saying that in this case r will be equal to 1. Means we will do the analysis on the radius, on the circle of the radius 1. Again, like Laplace transform, we have already seen that it is the counterpart of the Laplace transform. So jet transform also comes in two varieties. One is bilateral or two-sided jet transform, or unilateral or one-sided jet transform. So in case of bilateral jet transform, we will take the entire jet plane, means from minus infinity to infinity, and in case of one-sided jet transform, we will take only the values from 0 to infinity. And you know, the bilateral bilateral jet transform offers insight into the nature of the system characteristics such as stability, causality and frequency response. So whenever we are interested in finding out the stability of the system or the causality of the system, or if we want to obtain the frequency response of the system, then in that case this jet transform, bilateral jet transform is generally used. And unilateral jet transform, like similarly in the case of Laplace transform, we use unilateral Laplace transform for the solution of differential equations. Similarly here, in case of jet transform, we are interested when we are interested in the solution of difference equation, then we will take unilateral Laplace transform with initial conditions. Okay, now let us move to the next slide. So basically, if we are having a discrete time signal which is represented as xn, and it is defined by the formulas, like this is for bilateral jet transform and this is for unilateral jet transform. So you can see here the limit, the same expressions are the same, xn into z to the power minus n, but you can see the limit in the summation. Here the limit is from minus infinity to infinity, and here is the limit from 0 to infinity. It means we are taking the signal, positive value of signals, and here we are taking both negative and positive value of the signals, where z is, I have already discussed this, z is a complex variable, and we can represent jet transform by this representation, where xn is the signal and we will take the jet transform of it, so we will get xz, which is basically the jet transform of the signal. Now it is convenient to represent the complex number z as a location in complex plane termed the jet plane. So basically this, you can say it is the jet plane, and let us suppose we are taking this point on the jet plane. So this point in polar form can be represented by z equals to r e to the power j omega, where r is basically this radius and omega is the angle that is made with the positive real axis. So we can write it like z equals to r e to the power j omega. This is the polar form. So the point z equals to r, it was located at a distance r from the origin and at an angle omega from the positive real axis. Here r is basically the magnitude of z. So if you will take the magnitude of z, it means you will take the magnitude of r e to the power j omega. So you can write it like mod of r mod of e to the power j omega, and this will become mod of r. Okay, so because since mod of e to the power j omega will always become 1. Okay, so mod z will be equal to r, and omega is the angle of z. So this you can see is the angle. Now in terms of r and omega, we can represent the, or you can say z transform in polar form. We can represent like, we will put z equals to r e to the power j omega. So in the expression of z transform, or in bilateral z transform, we will put z equals to r e to the power j omega. Okay, so we can say that this value will become, you can write it like xn into r to the power minus n and e to the power minus j omega n. Now if you will see, the expression that we have seen for dtft is basically x e to the power j omega equals to n equals to minus infinity to infinity xn into e to the power minus j omega n. This is the expression for dtft. Now if you will compare it with this, then you will find that z transform is nothing but the Fourier transform of the signal xn into r to the power minus n rather than xn. So what this term r plays basically, this term r, you can say this term r is basically exponentially weighing function which may be decaying or growing with the increasing value of n, and depending on whether r is greater than or less than unity, we will get the values of this. So you can say why we are taking this r to the power minus n factor in the picture. Previously in case of dtft, what we have seen, previously we have seen that r is equal to 1, but this time because we are taking this term r to the power minus n, so what happened, by taking this term r into the picture, what happened that previously when we were taking dtft, then the issue was that xn is not basically absolute summable at the point, but when we are including xn into r to the power minus n, so due to this r term, what happened, xn into r to the power minus will become absolutely summable, so that we can apply the z transform over it. Okay, so if r equals to 1, so mod z will be equal to 1, and you can obtain the equation of dtft from the z transform itself by just putting z equals to e to the power j omega. Okay, so so this we can do always whenever we will find that our signal which is given is absolutely summable. Means for this we need to know the concept of ROC, key in which condition we can put this value z equals to e to the power j omega or not. We cannot always put this value. We can only put this value when the signal that we are having is also we can take the Fourier transform of that. Okay, so this is z transform reduces to dtft when the magnitude of the transform variable z is unity, or you can say mod z equals to 1. Okay. Now this is the important concept, region of convergence for z transform. Basically based on this region of convergence, we can define the values of z on which our system is basically converge. So since the z transform, if you will see here, since the z transform is an infinite power series, it exists only for those values of z for which the series converges. Okay, so for not all values of z, but we have to find those values of z for which this infinite series converges. Okay, so the range of values of mod z equals to r for which the z transform converges means it attains the finite value, means z transform attains the finite value is termed as the region of convergence. Okay, so we will check those values of z, check those values of r for which z transform converges, and those values are nothing but the region of convergence. Okay, so that is the ROC consists of those values of r for which the dtft of the xn into r to the power minus n converges. Now if we will limit ourselves to a certain range of values of r, we may ensure that xn into r to the power minus n is absolutely summable, even though xn is not absolutely summable by itself. Okay, so this I have already explained that you have to take we are taking this term xn into r to the power minus n rather than taking the term xn. So due to this xn into r to the power minus n term, your signal will become absolutely summable. Okay. And previously, if you have taken alone xn, then it was not absolutely summable. Okay. Another important thing is that ROC can also provide us with information about whether this xn is Fourier transformable or not. So what happened, if you will see, then the value of r is basically is a radius of circle. Okay. So radius of circle. So what happened, what is the condition of signal to become Fourier transformable also? If this circle is of radius 1, we have already seen if mod z equals to 1, and ROC is basically the plane which is you can say maybe somewhere here, means value of r may be anything other than 1. And if you will draw the ROC, and that let us suppose this is our ROC, so you can see in this particular case the radius of circle 1 is overlapped. This is the radius of circle 1, and which is overlapped by the ROC. So if we will calculate we will take the ROC for the given signal, or we will take the Z transform and draw its ROC, and if ROC covers the unit circle, in that case we can say the signal is basically the Fourier transformable also. Okay. So in that case, what we will do, we will simply put Z equals to e to the power j omega in it, and we will get the value of discrete time Fourier transform. So if from Z transform equations itself, or you can say from Z transform properties formulas, if we simply put Z equals to e to the power j omega, then we will get the corresponding values of DTFT, which is discrete time Fourier transform. Okay. So we will see the ROC of various type of signals which are discussed here. If our signal is, there are two cases, if our signal is infinite duration signal, and second is when our signal is finite duration signal. So in case of infinite duration, your signal may be right sided or causal signal, or left sided or anti-causal signal, or it may be two sided signal, which is a non-causal signal. And similarly, these three cases will be applicable for finite duration signals also. Okay. So we will see ROCs for these type of signals one by one. So let us start with case 1, infinite duration right sided causal or causal signal. Okay. So you can say in this case signal is causal, so you can say this is our signal. Okay. So which is lying only on which is existing for only positive values of n. So let us suppose we have taken xn, the value of xn let us taken as r1 to the power n, where n is greater than equal to 0. Okay. Now we will apply the Z transform over this signal xn. So we can say this is the formula for bilateral Z transform, summation n equals to minus infinity to infinity xn into Z to the power minus n. Now we will put xn equals to r1 to the power n here. So r1 to the power n, Z to the power minus n, where n is only applicable for n greater than equal to 0. So that's why this limit will be from 0 to infinity. Okay. So this we can write as r1 Z to the power minus 1 whole power n. Okay. So now this is basically an infinite series, and you know the value of this series is converges only when this term will be lying between 0 and 1, means the solution is possible only when this value r1 Z to the power minus 1 lies between 0 and 1. Okay. So you can say 0 is in between, r1 Z to the power minus 1 mod is lying between 0 and 1. So in that case, if it is so, then the solution is sum of infinite series. So first term upon 1 minus common ratio. So this will become 1 upon 1 minus r1 Z to the power minus 1, or you can simply if you will solve it, you can simply write it Z upon Z minus r1. Okay. So you can say the ROC for this signal exists. So condition to be satisfied for the convergence of xz is this r1 mod of r1 Z to the power minus 1 should lie in between 0 and 1, and from here if you will see, r mod of r1 Z to the power minus 1 will be less than 1, and r1 by mod z is less than 1, or you can say mod z is greater than r1, where r1 is the, you can say r1 is the pole from here. Okay. So our ROC will be the values of z which is greater than r1. Okay. So if this is the circle which is having radius r1, so ROC is outside this circle which is having radius r1. Okay. So you can say for infinite duration signal, ROC is outside the circle of radius r1, and it also includes z equals to infinity. Okay. So ROC of Xz is to the exterior of the circle of the radius R1 in the z plane. Okay. So this is the case of ROC when our signal is right sided signal, then mod z is greater than R1. Let us take second case where in finite duration left sided signal we have taken in the consideration, means signal is anti-causal, means it is defined only for negative values of n. In that case, let us suppose we have taken the signal as xn equals to r to the power n, where n is less than equal to 0. Okay. So again we will write the definition of z transform, and in that z transform we will put the limit. This time because n is less than equal to 0, so we will put the limit from minus infinity to 0, and xn will be r2 to the power n z to the power minus 1 z to the power minus n. Now we will put n equals to minus n, so that these limits will be changed. So limit will be from 0 to infinity, and in place of n we will write minus n. So here r to the power minus n z to the power minus z to the power n, which we can write as r to the power minus 1 z to the power n. Again this series converges only when this value lies between 0 and 1. Okay. So the this should be this condition should be met if we want to converge this series. Okay. So now when we will solve it, we will get 1 upon 1 minus r2 inverse z, this is the z transform, or you can say minus r2 upon z minus r2, where pole is lying at z equals to r2. So condition to be satisfied for the convergence of xz is, this is the condition, and in that case if you will see, you will find that mod z is less than r2. It means ROC is lying for the values where ROC is lying for those values of z which is less than r2. So you can say this, if this is the circle of radius r2, so this is basically the region of convergence which is shown in overlapping lines. Okay. So here mod z is less than r2. Okay. So ROC of xz is to the interior of the circle of radius r2 in z plane, and in this case if it is infinite duration signal, then z equals to 0 is also the part of the ROC. Let us take third case where the signal is two-sided or non-causal signal. So in that case signal can be represented like this, r1 to the power n un plus r to the power n u of minus n minus 1. Okay. Now we will take the z transform. Again we have written the definition of z transform. Then this is the definition. Now we have splitted it in two parts. For this limit will be minus infinity to minus 1. So r to the power n z to the power minus n here, and here for this term limit will be from 0 to infinity. So r1 to the power n z to the power minus n. So now we will put the values and solve it. Again here we will change the limit. So this will become r to the power minus n z to the power n, and limit is from n equals to 1 to infinity, and here is from n equals to 0 to infinity, same term. Now because this limit is from 1 to infinity, we can write it from 0 to infinity. For that we have to use it minus 1 here. Okay. So we will get these terms 1 upon 1 minus r2 inverse z plus 1 upon 1 minus r1 z inverse minus 1. Okay. So this series will be converged when this term will converge and this term will be converged. Okay. So for this term is corresponding to your anti-causal signal, and this term corresponding to your causal signal. Okay. So for anti-causal signal this term should converge. So if this term should be converged, then mod z is less than mod of r2, means this is the term which is corresponding to anti-causal signal. And if you will take this term and this term converges, so the condition will be mod z is greater than r1. So you can say ultimately what is the ROC? ROC should be lying between mod of r1 and mod of r2. Okay. So here you can say this is the circle r1. So mod z is the values which is lying outside of it, and r2 is basically this radius, so values are inward. So you can say this is basically the overlapping area. Okay. So you will get a concentric circle for case of non-causal signal. Another case is there when if this r1 will be greater than r2, and r1 corresponding to your causal signal and r2 corresponding to your anti-causal signal. In that case there will be no overlap and z transform does not exist. If here we have taken that r2 is greater than r1, but if we will change the condition, means r1 is greater than r2, in that case z transform will not exist for this signal. Okay. Now for similar things will be applicable for finite duration right sided signal or causal signal. In case of finite duration signal, our limit is from 0 to n minus 1 if our sequence consisting of n minus 1 n values. Okay, so n equals to 0 to n minus 1 xn z to the power minus n. Okay, so it means we will get the, when we will put the value, so we will get the negative powers of z. Okay, so due to this negative power of z, we can represent it also like this. So you can see here, if the value of z will become 0 at any point here, so the value of xz will become infinity, so it will not converge. So you can say ROC is the entire plane except z equals to 0, because when you will to calculate the value at z equals to 0, this xz will be infinity. So ROC is the entire plane except z equals to 0. Now you can solve one simple question, like if this sequence is given like this, so this is basically the z transform. Okay, so how you will put the limit from 0 to, how many terms are there? There are 0 to, there are 4 terms, so limit will be 0 to 3 and xn z to the power minus n. Now if you will expand, you will get first value x0 z to the power 0 plus x1 z to the power minus 1 plus x2 z to the power minus 2 plus x3 z to the power minus 3. Now if you will put the value of x0, x1, x2 and x3 from here, so you will get this. This is basically the z transform of the finite duration signal. And again, if the value of z will become 0, so this value will become infinity. So you can say z transform or only exist or ROC is the entire z plane except z equals to 0. Okay. Now case 5, finite duration left-sided signal or anti-causal signal. In case of anti-causal signal, you can say your limit will be from n equals to minus of n minus 1 to 0 xn z to the power minus n, and you are having positive values of z. Okay, so this is your anti-causal signal, let us suppose, and if you want to calculate the z transform for it, so you will put the limit, this value is minus 3, minus 2, minus 1, 0, so minus 3 to 0 and xn z to the power minus n. Okay, so you will meet, it means x of minus 3 z to the power 3 first value, second is x of minus 2 z to the power 2 plus x of minus 1 z to the power 1 plus x of 0. These are the values, so you will get this value. Now if you will see here, if z equals to infinity, then what happened, xz will be infinity. So you can say ROC for this signal entire z plane except z equals to infinity, because at z equals to infinity we are getting the value of xz which is equal to infinity. And last one is finite duration two-sided signal. So in that case the situation is like this, means you are having n values between negative and positive, and when you will solve it, so you will put the limit from n equals to, for this particular question, minus 1 to 3, sorry, minus 1 to 2. So it means there are 4 terms. So value, so first value xn z to the power minus n. So if you will solve it, first value is x minus 1 z to the power 1 plus x0 plus x1 z to the power minus 1 plus x2 z to the power minus 2. So this you will get. So in this case you can say both z and minus z powers and z to the power minus 1 powers are there. So you can say when z equals to either 0 or z equals to 0 or z equals to infinity, in both the cases xz will be infinity. So in that case entire z plane is the ROC except z equals to 0 and z equals to infinity. Okay. Now properties of ROC. So we have already seen that ROC of xz consists of a ring in the z plane centered about the origin. If xz is rational, then the ROC must not contain any poles. So in each and every case previously we have seen, wherever mod z value is there, it is greater than or it is greater than always or less than, there will be no equality sign. So you can say poles will not be the part of the ROC. Okay, so this is important one. And we have seen that if xn is right sided end of infinite duration sequence, then the ROC is the region in the z plane outside the outermost pole. Means if we are having a signal wherein two causal signals will be there, so we will take the value of pole which is outermost, means the maximum value of the pole we will take in that case. ROC also includes z equals to infinity in this case. And other than this, if xn is left sided signal end of infinite duration sequence, the ROC is the region in the z plane inside the innermost pole. Again the situation is like that, maybe it may happen that more than 2 anti-causal signals will be there. So the minimum value of pole will be taken as the innermost pole. Okay, so ROC in this case also includes z equals to 0. Now if xn is two-sided and of infinite duration, then the ROC will consist of a ring in the z plane. Okay, this is another property. Now for finite duration signal, right-sided signal, the ROC will be the entire z plane except z equals to 0. And for similarly, for a finite duration left-sided or anti-causal signal, the ROC will be the entire z plane except z equals to infinity, because we are having positive powers of z in this case. And for a finite duration two-sided signal or non-causal signal, ROC will be the entire z plane except z equals to 0 and z equals to infinity. This we have already seen. So basically these are the properties of the ROC of Z transform. Now we will see the properties of Z transform. So the properties are similar, like we have already seen in case of Laplace transform and for DTFT or CTFT, we have already seen these. But because Z transform is applicable for discrete time signal, so you can say these similar type of properties you have seen in case of DTFT also. Okay, so linearity property will be there, where a1 x1n plus a2 x2n, if we are having two sequences and a1 and a2 are constant, so we will get a1 x1z plus a2 x2z, where x1z is the z transform of x1n and x2z is the z transform of x2n. Then time reversal, if we will reverse in time, then the value of z will be replaced by z inverse in the z transform. Then time shifting, first shifting in right, so we will get z to the power minus k xz, where k is the unit by which we are shifting the signal in right side, xn plus k, where we are shifting the signal in the left by an unit k, so this will become z to the power k xz. Now convolution property, x1n convolution x2n means convolution in time domain corresponds to multiplication in z domain, so this can be written as x1z into x2z. Then correlation property, according to correlation property, r x1 x2l will be equal to r x1 x2z, or you can say simply you will take the z transform of first sequence and you will take the z transform of second sequence, and in second sequence you will replace z by z to the power minus 1 and you will get the value of correlation. Then scaling property will be there. So basically this is scaling property, means a to the power n xn can be written as x a inverse z. So this is the scaling property. Then differentiation property, differentiation in frequency domain you can say. So if we will multiply our sequence xn by n in time domain, then the value will be minus z dxz by dz, means differentiation in frequency domain. Now time differentiation, so time differentiation can be represented by xn minus x of n minus 1, means first difference, and we will simply take the z transform. So z transform of xn is xz and x of n minus 1 according to time shifting property will be z to the power minus 1 xz. So you will get 1 minus z to the power minus 1 xz. Then last two properties, initial value theorem and final value theorem. So these two properties are only applicable for unilateral Laplace transform, unilateral Z transform. So if we have to find out the initial value, limit n tends to 0 xn, so this value in frequency domain will become limit z tends to infinity xz. And in case of final value theorem, limit n tends to infinity xn will be limit z tends to 1 z minus 1 upon z times xz, or you can also write limit mod z tends to 1 minus z to the power minus 1 xz. Okay, so by this you can calculate the initial and final value of a given signal in time domain as well as the frequency domain. Now we will see the first problem, determine z transform and ROC of the following signal. Okay, so you can see this signal corresponds to, because un is there, you can say this is your causal signal and this is your anti-causal signal. Okay, so ROC is basically, so you can say this is a two-sided signal. So ROC will be the either the signal either the Z transform does not exist, or the second case ROC of Z transform is basically the concentric circles. Okay, so you know the Z transform of a to the power n un is basically, if you will calculate Z transform, this will become 1 upon 1 minus a Z inverse, or minus of a to the power n u of minus n minus 1 is also 1 upon 1 minus a Z inverse. But change in the ROC, here ROC is mod Z greater than mod a, and here ROC is mod Z less than mod a. Okay, so according to this we will get the result 1 upon 1 minus 0.5 Z to the power minus 1. Okay, and for this minus 1 upon 1 minus 0.8 z to the power minus 1, or you can also write z upon z minus 0.5 minus 1 minus z upon z minus 0.8. Okay, so when you will solve it, you will get this value, okay, minus 0.3 z upon z square minus 1.3 z plus 0.4. Now we will see the ROC. What will be the ROC? For this, ROC will be, for this term ROC will be mod z greater than 0.5, and for this term ROC will be mod z less than 0.8. So you can say your ROC for this signal is lying between 0.5 and 0.8. Okay, so you can draw it like this. This is the circle of radius 0.5, this is the circle of radius 0.8. Okay, so for radius 0.5, ROC is outside, okay, like this, and for r equals to 0.8, ROC is basically you can say ROC is inside, means like this. Okay, so you can say which will be the overlapping region. Overlapping region, you can say this is basically the overlapping region, this one is the overlapping region. Okay, so you can say ROC will be lying between 0.5 and 0.8. Okay, so this is a simple question. Next one, determine Z transform and ROC of the following signal. Xn equals to sine omega naught n un. Okay, so you can always represent sine omega naught n in terms of complex exponentials. So we can write it 1 upon 2j e to the power j omega naught n minus e to the power minus j omega naught n un. Okay, so now according to, if we will take the Z transform according to the linearity property, we can write it xz equals to 1 upon 2j Z transform of this term minus 1 upon 2j Z transform of this term. Okay, now here it is a to the power n un, a to the power n un. So the formula we have already discussed is 1 upon 1 minus a z inverse. So here a is this. So you can say 1 upon 1 minus e to the power j omega naught z to the power minus 1, and here 1 upon 1 minus e to the power minus j omega naught z to the power minus 1. And ROC is what? For both these cases, mod z, ROC is mod z greater than e to the power j omega naught, or mod z is greater than e to the power minus j omega naught, and you know mod of e to the power j omega naught or e to the power minus j omega naught will be nothing but equal to 1. Okay, so that's why we have written as mod z is greater than 1, and when we will solve this, we will take this term as an LCM, multiply it, and when we will solve, we will get the final result xz is this, where mod z is greater than 1, which is the ROC for this particular signal. Okay, now next question, determine Z transform and ROC of the following signal using time shifting property. Okay, so according to time shifting property, because you know, if our signal is a to the power n un, then what happened? If we will take Z transform of it, so we will get 1 upon 1 minus a z inverse, or you can also write it z upon z minus a. Okay, now what I am doing, I am shifting this signal sequence, I am writing it a to the power n plus 1 un plus 1. So what I am doing here, I am just shifting this sequence by unit 1 in left side, so that we can represent it a to the power n plus 1 un plus 1. So in that case, what happened, when we are doing here, the value of power of z will be 1. Okay, so the final result will be z according to this time shifting property and z upon z minus a previously. Okay, so the final result will become z square upon z minus a, and again ROC will be not change in case of ROC will not change in case of time shifting operation. So ROC will be mod z greater than mod a. Okay, so xz for the given sequence is basically z square upon z minus a. Okay, isn't? So this we have used the time shifting property. Okay, now determine Z transform and ROC of the following signal using scaling in Z domain property. Okay, so so let us suppose our sequence Gn is a to the power n sine omega naught n un, and what we are writing, we are taking this sine omega naught n un as xn. Okay, so now our sequence will become a to the power n xn, and let xn will be sine omega naught n un, means for this we are writing it as xn. Okay, and we have already calculated the Z transform previously of term sin omega naught and un. From there we will directly write this Z transform, which is Z to the power minus 1 sin omega naught upon 1 minus 2 Z inverse cos omega naught plus Z to the power minus 2, where mod Z is greater than 1. Okay. So according to scaling in Z domain property, Z transform of Gn will be Z transform of a to the power n xn, and when we are taking the Z transform of a to the power n xn, then the Z transform of it is Gz will be x of Z by a. So what we will do, in place xz that we have obtained, we will replace Z by a, Z by a. Okay, so in place of Z we will write in Gz Z upon a, so Z by a inverse, so it means a Z inverse. Okay, and similarly here Z by a, it means Z by a to the power minus 2, it means a square Z to the power minus 2, and here a 2a Z inverse will be there. Okay, so this is the term, and this time when we are scaling in Z domain, then the ROC will be multiplied by the scaling amount. Okay, so here the ROC will be mod Z greater than a, so now we will multiply by a, so ROC will be mod Z greater than mod of a. Okay. Now determine Z transform and ROC of the following using differentiation in Z domain property. So this is another property. So let us suppose the sequence Gn is given n a to the power n un. Okay, and what we are writing here, we are assuming that this a to the power n un is xn, let us suppose. So xn equals to a to the power un, a to the power n un, and we know the Z transform of this xn, which is 1 upon 1 minus a Z inverse, and because un is there, so we are writing mod Z is greater than mod of a. Okay, now according to this differentiation property, Z of Gn means Gz will be equals to Z of nxn. Okay, so nxn, Z, according to this property, n of xn, if we take Z transform, that it means that will become minus Z dxz by dz. Okay, so I have using this property, so Gz will become minus Z dxz by dz. So what we will do, we will take the differentiation of this term and we will multiply by minus Z. Okay, so we will get Gz equals to a Z inverse upon 1 minus a Z inverse whole square, and in this case there will be no change in the ROC, so we will get mod Z greater than mod a. Okay, now so this we are getting the value of n a to the power n un. Okay, now we can change something in this values to obtain some important results, like this a can be come over here. So 1 by a n a to the power n un will become Z inverse upon 1 minus a Z inverse whole square. Then we are shifting this whole sequence by an amount 1 in left direction. Okay, so this is 1 by a, in place of n we will write n plus 1, so n plus 1 a to the power n plus 1 un plus 1. So what happened when we are doing this? So we have to multiply by Z in the numerator. So what happened, this Z to the power minus 1 will become now 1. So 1 upon 1 minus a Z inverse whole square mod Z greater than 1, mod Z greater than a. Okay, and also this a can be cancelled this, so here a to the power n, n plus 1 a to the power n, and un. Why I am writing u, and in place of un plus 1 I have written un? Why? Because at n equals to minus 1 the value is 0, because it is causal. Okay, so we can write it, so this is the important result which we have obtained, n plus 1 a to the power n un will be 1 upon 1 minus a Z inverse whole square. Okay, this is again the simple question. Determine the convolution of unit step function un with itself using convolution property. So let us, so our sequence is xn equals to un convolution un, and you know the convolution property of Z transform. According to that property, Z transform of it is convolution in time domain corresponds to multiplication in multiplication in Z domain. So uz into uz, and uz means Z transform of un will become 1 upon 1 minus Z to the power minus 1. So xz will become 1 upon 1 minus Z to the power minus 1 whole square. And for this we have already seen from here the formula will be here, if a equals to 1, then you will get n plus 1 un is 1 upon 1 minus Z to the power minus 1 whole square. So you can say for that inverse Z transform is n plus 1 un. Okay. Now this is this simple problem for initial and final value theorem. Okay, so initial value x0, this is the term xz equals to 2 plus 3z to the power minus plus 1 plus 4z to the power minus 2. So initial value theorem means for x0, for n equals to 0, we will put mod z tends to infinity. Okay, so we will put z equals to infinity. So we will get the value 2. This is initial value, and in final value theorem we have already seen x infinity will be limit z tends to 1 minus z to the power minus 1 xz, where xz is this term. So when we will solve it and put z equals to 1 in this, we will get the value 0. So initial value is 2 and final value is 0. Now come to the inverse z transform. So inverse z transform of xz is basically given by this contour integration formula 1 upon 2 pi j closed integral xz into z to the power n minus 1 dz. So this is basically the complicated formula, and generally we don't calculate the value of signal using this formula. We are having well defined methods like 3 methods: contour integration method, long division method, and basically the partial fraction method. So using these 3 methods we can find out the inverse z transform easily. Contour integration method uses this method. Okay, so first contour integration method, so formula is this, where the integral is a contour integral over a closed path C that encloses the origin and lies within the region of convergence of xz. So what we have to see, basically we have to take a closed region C in such a manner that that closed path C must lie within the ROC that is given in the question. So the contour is any circle of radius r in the region of convergence. So we will calculate residues in this case. Okay, so the contour integral can be evaluated using the standard techniques from complex variable theory. So according to Cauchy theorem that we have already studied in case of mathematics, this theorem says that if fz is single valued and analytic on and inside a closed contour C except for a finite number of poles inside C, then okay, so this theorem says that first of all we have to take a function fz which need to be analytic. So analytic functions are basically those functions which does not pass through the singularities or the poles, and it also should be single valued. If it will not be a single valued, then in that case we will not get the closed path when we will do the mapping. Okay, so this is basically you can say this is basically the inverse z transform formula, which is equal to the residues of all the poles which is lying within the contour C which we have taken. Okay, so you can say it is equal to residues of the term xz into z to the power n minus 1, okay, for all poles. So this is the expression for calculating the residue, where m is the order and alpha is the pole at which we are calculating the residues. Okay, another method is the power series expansion method. So this is the bilateral formula, bilateral z transform formula. So in this case we are having the values, negative values as well as positive values. Okay, but in case of power series expansion method, it means you can represent your signal xz in terms of either negative powers of z or in positive powers of z. Okay, in z to the power minus 1 or z of the form defined in the above equation. Okay, so important thing is that we cannot take positive and negative values simultaneously. Means z powers we cannot take positive and negative simultaneously. So we will not get from this method, we will not get the closed form solution. We will get the solution either in positive powers of z or in negative powers of z, but we cannot do it for this, we cannot do it simultaneously. Okay, so the values of the signal xn are then given by the coefficients associated with z to the power minus n. This inversion method is suitable to signals that are one sided, that is discrete time signals with ROCs of the form mod z is less than a or mod z is greater than a. That's I have already explained. Means whenever you are interested, whenever you are not interested in all the values of xn, means you only want the value of signal at some of the discrete points, and either those points are causal one or anti-causal one, not for non-causal. Okay. So the disadvantage is long division may not lead to the closed form expression for xn. Okay. So partial fraction method are the most important method, or you can say most useful method for finding out general expression for the discrete time signals corresponding to a rational z transform, rather than in finding just the first few samples by power series expansion method. Okay, so in case of power series expansion method, because we are only getting one sided signal, but here we will get the complete solution. Okay, so now we will see the problem. First problem is based on residue method. So using residue method, find the inverse z transform of xz equals to 1 upon z minus 0.25 and z minus 0.5 using continued integration method, where ROC is given as mod z greater than 0.5. So important thing is there, because ROC is greater than mod z 0.5 and our poles are at 0.25 and 0.5. So it means both these poles will be covered by the closed contour. Okay. So first of all, we will make the function xz into z to the power n minus 1, which is the analytic one. So we will multiply this term by z to the power n minus 1. So we will get this term. Now we are writing this term, let's say x naught z. So we are getting this value. Okay, what we are doing basically here, the term z to the power minus 1 will be there, which we are writing over here. So now this will consist of three poles, z equals to 0, z equals to 0.25 and z equals to 0.5. So what we have to calculate, basically we have to calculate the residues by these three poles. Okay, so now we are calculating the residue according to the formula, which you know this formula. So when we are calculating corresponding to z equals to 0, and important thing is that here order is 1. Okay, so 1 upon factorial 0 will be 1. So limit z tends to 0, and 1 is when m is 1. So this term will also vanish. So only this term will be there. Okay, so z minus 0 to the power 1, yani z, it means z xz into z to the power n minus 1. So it will become z to the power n upon this term. Now you will put z equals to 0, so you will get the value of residue 0. Similarly, for z equals to 0.25 point, we have calculated it, and when we will get, so we will get this is the final value. Okay, and when we will put z equals to 0.25, we will get this value minus 16 1 by 40 to the power n. Similarly, for pole z equals to 0.5, we are getting the value 8 1 by 2 to the power n. Now we will added up all these residue values. So this is our sequence. This is the final result, you can say, for applying the residue method. Now using long division method, determine the inverse Z transform. So there are two cases given. First, when mod Z is greater than 1, and second is when mod Z is less than 1 by 2. So when mod Z is greater than 1, it means you can say here we are interested in a causal signal where mod Z is greater than 1. So for causal signal we require negative powers of Z, and here mod Z is less than A, so we require positive powers of Z. So what we will do, we will write this fraction in this term. Numerator part is denominator part is here and numerator part is here, and we will take the values like that, so that these term will become vanishes, and we are getting here the negative powers of Z. So first of all we will choose the value 1. So according to 1 we will get 1 minus 3 by 2 z to the power minus 1 plus 1 by 2 z to the power minus 2. Then we will minus it. So this term will be 3 by 2 z to the power minus 1, and this term will be minus, so minus 1 by 2 z to the power minus 2. Now we have to vanish this term 3 by 2 z to the power minus 1. So we have to put the value 3 by 2 z to the power minus 1, so that when it will multiply here, we will get 3 by 2 z to the power minus 1. But from this we have to multiply all these terms also. So you can say our aim is to vanish the first value whatever we are getting here, and according to that we are getting the values here, and so you can get some term. So you can say the answer is directly the coefficients of powers of Z. So first value will be 1, then 3 by 2, then 7 by 4, then 15 by 8, then 13 1 by 16 up to so n. So these are the values. Okay. And second case, this I have already written. Second case, ROC is mod Z 1 by 2, less than 1 by 2. In that case we are interested in positive powers of Z. Okay. So we will write the term like previously we have written 1 first, but right now we are writing the highest negative power first, and we will eliminate this term. Okay. So we will write 2Z square, so that this term will be vanished, so 1 will be there, and we will get this value. So here our aim is to vanish the first term which we are getting after elimination. Okay, so that we are getting this term. So again xn, here you can see that 2z square means if we are writing it, means there is no constant term and no z term. Okay, so it means this value is 0, this value is 0, and this value is basically 2, then 6, then 14, then 30, then 62, and before this dot 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 will be there. Okay, so you can see this is basically the solution here. Okay, and the last method is partial fraction method. For determining the inverse Z transform, we will take three cases: when mod Z greater than 2, mod Z less than 1, and mod z is lying between 1 and 2. Okay. So first of all, what we will do in this case, we will write this transfer function in positive powers of z. Okay. So we will get this. Then what we are doing, we are taking this term z here. So xz by z equals to 3 upon z minus 1 times z minus 2. Okay. So we can write it like when we will do the partial fraction. So we will get two terms, minus 3 z upon z minus 1 plus 3 times z upon z minus 2. Okay. So you can see here are the poles are located at z equals to 1 and z equals to 2, and you require the ROC mod z greater than 2. So what happened, when we will take the inverse z transform, then we have to see that when we will get this ROC. So this ROC can only be obtained when one circle which is of radius 1 and another circle which is of radius 2. Okay. So this is only happen when ROC will be this. This only happen when ROC due to this circle and due to this circle will be outside. Okay. So this is the basically the you can say the region where the ROC will be common, or you can say we will get the solution. Okay. So in that case, when both the signals are corresponding to causal signal, so we will get a causal signal. So you can say for this term we will write a causal signal formula. Okay. So 1 upon 1 minus z to the power minus 1 is basically you can say minus 3 un plus 3 into 2 to the power n un. Okay. Because 3 term is here, and 1 upon 1 minus a z inverse is a to the power n un. Okay. Second solution, mod z is less than when both signals must be anti-causal, because poles are at z equals to 1 and z equals to 2. So for z equals to 1, let us suppose this circle will be there, and for z equals to, let us suppose this circle will be there, and you want ROC here. Okay. So this ROC will be here only when due to this solution will be anti-causal, and also due to this solution will be anti-causal, only then we will get this. So for both these terms we will write anti-causal formula. Okay. So this will become 3u minus n minus 1, and this will become minus 3 2 to the power n u of minus n minus 1, because term minus a to the power n u of minus n minus 1 is nothing but 1 upon 1 minus a z inverse. Okay. Then the last one is the mod z is lying between 1 and 2. So you can say for this one signal with pole z equals to 1 must be causal, and second signal corresponding to pole z equals to 0 must be anti-causal. Only then we will get this ROC. Okay. So the pole that is corresponding to z equals to 1 is signal is the first signal. Okay. So you will write for this, the expression is basically causal one. So you will write it minus 3 un, and for second one this is anti-causal. So this is minus 3 2 to the power n u of minus n minus 1. You can say this term will be there and this term will be there here. Okay. So this is basically the solution for inverse Z transform using the partial fraction expansion method. Okay. So thank you. So if there is any queries, you can ask in the chat box. Otherwise, if there is any issue, you can ask. Okay, if there is no issue, there is no queries, I am ending this session. Thank you so much.